Introduction to Cartesian Planes. Cartesian plane, Cartesian coordinate plane, and coordinate graph are all terms that are used to describe the same thing. The word plane refers to two dimensions, a flat surface. Cartesian coordinates, such as 4, 3, are ordered numbers that relate points on the plane to two perpendicular lines. Coordinates can be used to identify points on the plane, and lines can be drawn between the points to make a graph. Here's what it looks like. This horizontal line is called the x-axis, and you can see that it is divided into units. They're equal size, and they are increasing positive numbers as they move to the right. So this is 1, 2, 3, 4, 5, and so on, and decreasing numbers as they move to the left. So we have 1, 0, -1, -2, and so on. The units could potentially go on forever, which is why we have arrows at each end of the line to show it could go on indefinitely. This line going up and down is the y-axis, and it's also divided into units of the same size. They are increasing positive numbers going up, so we've got 0, 1, 2, 3, 4, 5, and so on, and decreasing numbers going down, so we've got 2, 1, 0, -1, -2, and so on. The space between the lines that mark the units on the x-axis and the y-axis should be the same. So these units and these units should physically be the same size. The place where the x-axis and the y-axis cross is called the origin, and the coordinates there would be 0 on the x-axis and 0 on the y-axis. A Cartesian plane is also commonly thought of in 4 coordinates that are numbered counterclockwise. In coordinate 1, the numbers here along the x-axis are positive, and they're positive along the y-axis too. In quadrant 2, the numbers along the y-axis are positive, but the numbers along the x-axis are negative. In quadrant 3, the numbers along both the y-axis and the x-axis are negative. And in quadrant 4, the numbers along the x-axis are positive, but along the y-axis they're negative. Here's how it works. Every point on the plane has two coordinates. The x-coordinate is given first, and then the y-coordinate is second. For example, look at this point right here. You can see that this point lines up with 1, 2, 3 on the x-axis and 1, 2 on the y-axis. So the coordinates of this point are 3, 2. Let's try another point. You can see that this one lines up with -1, 2, 3, 4 on the x-axis and -1, 2, 3, 4, 5 on the y-axis. So the coordinates are -4, -5. So what's all this useful for? Well, it can be useful for all kinds of practical things. You can use it to plot individual pieces of information. So for example, let's say we're tracking data for professional apple pickers. And the x-axis is going to be the number of hours worked, and the y-axis is going to be the number of bushels of apples that they picked. Nate worked 2 hours and picked 1 bushel. Marcus worked 4 hours and picked 4 bushels. Sam worked 3 hours and picked 3 bushels. Sean worked 5 hours and picked 4 bushels. Deborah worked 3 hours and picked 7 bushels. Just by looking at the dots, we can draw some conclusions. This clump of dots right here probably suggests that these people are working at about an average rate because their dots are close together. Now this person is probably not a very good employee. He didn't work very long and didn't pick many apples. This employee seems to be very efficient. She picked many more apples than everyone else during her period of time. And we can tell about these last two because their dots are separate from the others. Another thing we can do, if there's a pattern, is draw a line. And this line might represent a linear equation. So for example, let's say Marcus gets paid $2 for every bushel of apples he picks. We'll let the x-axis represent the bushels, and the y-axis represent the dollars. Well, if Marcus doesn't pick any apples at all, he gets nothing, so that's 0, 0. If he picks 1 bushel, he gets $2. If he picks 2 bushels, he gets $4. Now, if we were to draw a line connecting these dots, it would show the pattern or the equation. We have to start at 0 because logically Marcus can't pick fewer than 0 bushels. But after that, this line shows how much Marcus will be paid no matter how many bushels he picks on into infinity. Not only that, but let's say Marcus could get paid for partial bushels. How much would he get paid for picking 2.5 bushels? It would be right about here. Every point on this line could represent how much he gets paid. What we've done here is graph an equation with 2 variables. $2 times the number of bushels, which is x, is equal to the amount of pay, or y, where x is greater than or equal to 0 because he can't pick fewer than 0 bushels.